Good afternoon, everyone. My name is Martin Suberg. I'm the Executive Director of the Northeast Waste Management Officials Association, NUMOA, and we want to thank you for joining us on this webinar today. We are very pleased to have Brynn Mosello, the Director of Recycling and Communications at Mazza Recycling in New Jersey, provide this tour, including a virtual tour at one part of her presentation of their facility, as part of our ongoing efforts to learn about new opportunities and issues in solid waste management and recycling. This is a go-to webinar platform that you're viewing this on. You are currently muted. This is being recorded. This recording will be put up on the NUMOA website within a few days after its preparation, along with the slide materials that you're seeing. And again, it will be a resource that's available for either you or for people that maybe couldn't attend today. While you're on mute, there is a way to ask questions, and we encourage you to do that. There is a question button over on your control panel. If you enter the questions, I will be gathering the questions, and we'll make sure that Brynn gets to as many of them as possible in the time we have. The presentation will go for about an hour, and then we'll have the questions afterwards. We want to make sure that Brynn has the opportunity to get through the presentation. But again, we encourage you to ask questions, and we'll try to get to as many of them as possible. So with that, I want to really once again thank Brynn Mosello for joining us today, and I'm going to turn the floor over to you now.
Great. Thank you so much, Martin. Thank you for having me today. I'm really excited to give you guys a virtual tour of our facility. Again, let me introduce myself a little bit. My name is Brynn Mosello. I am the Director of Sustainability and Communication at Mazza Recycling. We're located right in the middle of New Jersey, close to the shore. We are one of the largest facilities in the country in terms of the diversity of our business and the types of material we're able to handle, as well as our newest addition, which is our material recovery facility, is also one of the largest on the East Coast. It was recently built in 2020, so that's why it gets a lot of attention for being one of the most updated state-of-the-art facilities out there today. It was designed by Van Dyke Recycling Systems. They do a really awesome job. They've built a lot of plants in the world as well as in the country. So we are very proud of our facility. I'm going to give you guys an inside look today. I started working in this industry about 5 years ago. I don't know, my computer is doing something funny, so I don't know what happened. Maybe it stopped sharing my screen. Hopefully everything looks okay.
We're still seeing your screen, but it's kind of in preview mode or edit mode. There we go. Now we see it in the regular mode.
Thank you. I don't know what happened. Sorry if I have any technical difficulties. So anyway, in a nutshell, I started working in this industry about 5 years ago. I'll talk to you a little bit about our company and how we got started. When I started here in 2018, the company as it's known today, Mazza Recycling, was only a year old. We started as a construction and demolition company. Well, I say we, that was prior to me starting here, but the current leadership, they are third generation overseers of our company. Our president and CEO is James Mazza Jr. and his cousin Dominic Mazza Jr. They took over in 2017 from their fathers, who bought this land, as you see in the background of this slide here. We operate on 55 acres. We have about 100 acres of property, so we're always looking to grow and expand. I'm going to turn my camera off so you guys can see the slides a little bit better. There we go. So that's a little bit of our history. In 2015, we began Mazza Mulch, and if you look at the lower part of this screen here, you see our entire mulch operation, which looks like just a bunch of piles of dirt and topsoil and things like that. We are one of the largest wholesalers of mulch in the greater New Jersey area. That operation operates on about 20 to 30 acres right there. So you see some of our guys on top of those piles, and we are a Class B facility, so that means we recycle all organic leaves and wood and things of that nature in order to manufacture and sell mulch and topsoil. So that's one of our operations. Our leadership team I spoke a little bit about already, DJ and Jimmy Mazza. And here's a little bit more of what we do. We have a collection side of the business. So we have some commercial roll-off containers and front-end containers to rent. We also have single stream recycling, which is what I'm going to get into today. That's how our material recovery facility processes material through a single stream recycling method. We also have a transfer station. So we do construction demolition waste disposal, bulky waste disposal, tire recycling. We also manufacture and sell recycled concrete at our facility. We have a scrap metal recycling yard here, as well as a satellite scrap metal yard in a nearby town. And we also do the wood and brush disposal, which is how we manufacture our mulch. So this is what our concrete operation looks like. It's just a small snapshot there of how that works. We basically take all of the concrete, cinder blocks, stone, brick, porcelain, tiles, things of that nature, and we recycle it into two end products, which is a crushed concrete one, which you see in this picture here. Those are larger rocks and stones that have gone through a grinding process and have been screened so that there's no metal or any other type of material in there besides a very natural aggregate stone. And then we also take the fines, which is our crushed concrete too, and that is smaller dirt that is all clean, natural aggregate that's also used for construction purposes, filling and leveling, things like that for foundations for large buildings and roadways. This is inside of our transfer station. We're at 1,100 ton a day transfer station. So while we don't always have that much material, we definitely are taking in a large volume of construction debris. So we'll take out any natural wood or pallets that we see, and we'll bring that over to our mulch operation. We'll also take out any scrap metal that we see, or we'll take out any bulky plastics and also clean cardboard. So we're looking for some recyclable material in the transfer station that will manually sort out and recycle. However, in New Jersey, we ask that people do recycle at the point of generation so that none of that recyclable material ends up in the transfer station, and then it has a better chance of not ending up in the landfill. But other things that do go to landfill are larger items like appliances, furniture, not tires, but I don't know what that's on that slide. We also do a lot of clean outs and drop containers at sites where there might be a demo job or a house construction or remodel job as well. Here's a little bit more about our mulch facility. You guys can see some closer pictures there. And we manufacture landscape products, including different dyed mulches, compost, and topsoil. That's a picture there of some of our red mulch. We also have black and cherry brown. We just began bagging some of our mulch this year, so we have a new bagging facility, which I don't have any pictures of yet, but if you guys are ever in the area and want to learn about some mulch bagging, please feel free to come on by and check out that facility. And then we are also permitted to accept tires. We take cars, we scrap them, we want the tires, we take out the rims, and then we ship them to a processing facility that we don't do anything with the tires besides transload them, but the processing facility will shred them and use them for mulch and things like that. So scrap metal is one of our other operations. We do all different types of metals. Like I said, cars, trucks, buses, we'll scrap them. We also do some precious metals. We have a copper room where we'll weigh smaller metal, and we'll pay for people to bring metal in a small amount, large amount, whatever you got, we'll take it and we will recycle it. And then we also have our award-winning material recovery facility, which is probably what you guys are gonna have the most questions about. So let me get right to it. If you don't know what a material recovery facility is, it is step 3 in this process, or rather step 1 is it comes from your curb and ends up in our material recovery facility. So it just gets transported. We at Mazza don't do any of that transporting from the curb side. We collect it all from third-party haulers and municipalities. They have their own trucks. A lot of the times we'll also send trucks down to one centralized location and transport them that way. So we're taking material from pretty much all the central Jersey counties currently, and we process about 40 tons an hour on average in our recycling plant. So our plant consists of manual and mechanical components. So we have about 50 employees inside the MRF. That includes administrative employees, supervisors, sorters, forklift operators, and we have 2 shifts that run, so that's 50 employees total between the 2 shifts. We run about 12 hours a day, and we clean the facility about 2 hours a day. And we also do a really deep cleaning of the facility every Saturday, so it requires a ton of maintenance to keep it clean, running efficiently, and working as best as humanly possible. And then we bale it and we ship it to different markets, mostly within the United States, but a few paper recycling facilities overseas. And this is what we are permitted to accept. Now, this is not an all comprehensive list. This is something that I share with our local municipalities. I bring to community events, share with residents. We're working on a couple new exciting projects that I will talk to you guys about in a little while, but things like toothpaste tubes, empty Keurig pods, clean aluminum foil. Some of these things were not previously accepted in MRFs, so maybe in your town, if your facility doesn't accept this same type of material, maybe they don't have the means to do so, or they don't have the optical sorting technology, maybe they don't have the proper end markets, so they won't take some of these things. So I do want to throw that disclaimer in there, but we'll take them. Toothpaste tubes are now going to be using HDPE, which is number 2 plastic. So that's one thing that we share with our local residents. And we also accept polypropylene, which is what the Keurig pods are now made out of. So a lot of these packages that you've seen on the shelves in your local supermarket, they're changing. So as those new products are changing over, we're also changing our information that we pass on to our residents. And we do try to include more hazardous materials in our do not throw these things in your curbside bin section. So although, you know, batteries, styrofoam, electronic, shredded paper, they're very recyclable materials. We just don't want them in our plants because it is hazardous to our workers, our equipment. We don't take any plastic film in New Jersey. It wraps around our screens, which you'll see in a little bit. So we are targeting those items to be separated and removed from our system prior to entering the facility. So I'm going to now walk you guys through each component of our material recovery facility so that you can see how it works. I'm going to explain it a little bit, and then we'll have a video that goes further in depth of what that looks like. So don't worry if it's seeming like a lot of things at one time getting thrown at you. It definitely will make more sense when you see it in the video. So we obviously opted to put a lot of bells and whistles in our facility, a lot of different sizing screens and optical sorters. We really know how advanced that technology is through doing a ton of research, visiting plants all over the country and looking into the latest and greatest technology available. That's what we opted to do. We are really trying to do the responsible thing and divert as much material as possible from the landfill, We will not be one of those facilities that says we do not take glass, we do not take certain types of plastic containers because of the size or shape of the bottle. We really want this technology to do the heavy lifting for our workers and make it easier for them to identify the materials necessary to pull out from the stream, and then everything else, the optical sorters do the work in identifying that material and what it consists of. And we have no problem moving these materials. We started shipping our materials out and doing single stream recycling well after China enforced all of its strict rules in the market. So we never had to deal with that problem, and we don't have any problem with the materials that we sell. So the tip floor is the first component of the MRF. When the trucks come in, they dump everything into this pile. Like I said, it's collected mostly by third-party haulers. We do have a couple trucks that come in. It's probably about 85% residential material at this point, so a very small portion of that is commercial material, but it does all get mixed into this same pile that you see here, and that loader operator kind of tosses it like mixing a salad to make sure that the material is even, and that's the best way for the equipment to handle that material, is by having a nice even blend of different types of cardboard, paper, metal, containers, glass, plastic. So after they dump onto the tipping floor, we have somebody grading the material, pulling out anything that shouldn't be in there at the ground level, and then we have a drum feeder that is evenly dispersing that material up an incline conveyor belt, which you'll see in the video. That is the start of our system. So it's separating that material, making it nice and loose, and making sure that there's not any large mounds of material or piles where like material is very hidden under other types of materials. So we want to give our pre-sorters a good chance to see everything. So that's why we installed a drum feeder. And then we have our pre-sort station where we have four sorters who are the guardians of the system. Their job is to pull out any material that might be hazardous or too large for machinery to properly sort. So right past this pre-sort, you'll see one of our first sizing screens. It's our OCC screen. But before it goes through a screen, we really want our pre-sorters to capture any film or things that might get wrapped around those screens, things like garden hoses, wires, Christmas lights, things of that nature, really large pieces of film. They're not really looking for any non-recyclable plastics or styrofoam or anything like that. That's not really their job. Their job is to pull out anything too large. There's also bunkers labeled bulky plastic and bulky metal on either side of them. So we do recycle bulky plastic and bulky metal, so we opted to pull those out at the start, and directly below those bunkers are two giant roll-off containers that fill with those types of material so that we can make sure to collect them even though they're pulling them out of this particular division. So here's a picture of that OCC screen that I mentioned. So your Amazon shipping boxes, all of your large packages, they come in what's called corrugated cardboard or old corrugated cardboard, hence OCC. And that is because we want to remove the largest commodity in the stream first so that we have better burden depth and view of all the other types of material. So the OCC goes up and over that screen, it's positively sorted, and then all the other three-dimensional containers and smaller pieces of paper will fall through the cracks and travel further down the line. So that's called positive sorting versus negative sorting. So the OCC, which is the positive sort of this screen, ends up on a quality control belt. And directly below that, there is also a glass breaker that will agitate the glass and break it into finer pieces, and then it gets bunkered and stored where it's eventually shipped to a glass processing facility. So that's the two things that get removed first, OCC and glass. And then we have quality control lines on each one of these positive sort lines. So the first one, which is the OCC, that gets positively sorted. This actually isn't a picture of it here, so don't be confused by the material on the belt, but this is just one other example of one of our quality control lines. Our sorters are looking for any contamination on those belts. So on the OCC belt, maybe there's a plastic jug that got, kind of stuck inside a larger piece of cardboard, or was hidden underneath, or maybe just large enough to make its way up and over the screen. So the quality control people there are kind of moving the moving the cardboard flattened boxes around to look for any of that plastic so that they can rerun it back into the system. And they're also pulling out any trash, which is again, plastic film or things like that will contaminate the OCC bale. So that's a picture right there of our quality control workers on our hard mix line. So you can see they're kind of throwing some tissue paper or plastic film into the trash bunker, and this guy is actually throwing that plastic bottle over to the rerun side, which is going to allow it to go back in through the system and get recovered in the correct area. And then I already mentioned the glass breaker, which sits below our OCC screen. So that's kind of what that looks like. It creates really fine shards of glass from all that material. And then we also have another sizing screen that separates paper from containers. ONP stands for old newspaper. We have two different fiber optics, which I'll show in a little bit. So here we're really just removing the residual paper that made its way past the OCC screen and separating that from the containers. So the three-dimensional containers go down further the line, they get negatively sorted, and the paper gets positively sorted over that screen in that picture there. And then you see our first we're going to talk about the deft air systems. So the deft air works in tandem with the optical sorter. It's allowing that lighter material like paper to stay on the conveyor belt and stabilizing things to prevent it from floating up and over the belt or creating a large mess everywhere. So that's what deft air is in place to do. And then if you look in the picture here, you'll see an auto sort computer and another orange box to the right of it that says Tamra on it, and that is an optical sorter. So we have a couple that look like that, but we have two that are designated fiber optical sorters. So we have 5 total. They all look exactly the same, but the fiber optics are each looking for 2 different grades of paper. So one grade of paper we recycle is a hard mix. So that would be any of your remaining OCC, smaller pieces of cardboard, any chipboard, so like cereal boxes, magazines, really like envelopes, computer paper, anything like that, that is a blend of paper. And then we have a second one that's looking for newspaper. So what the optics are really good at is identifying the characteristics based off of light and mirror detection. So the light reflects off all these different types of materials in different ways. It reflects off different colors in different ways. It's got some artificial intelligence in there as well that's able to tell the difference between a newspaper, like a grayish white kind of thin paper versus a thicker and more colorful piece of paper. And it's ejecting little puffs of air, which you'll see in the video. Kind of, I slowed it down a little in the video because in real life it goes super fast, so it's a little hard to detect, but you can hear those puffs of air, and what they're doing is they're ejecting the material that that particular optic is looking for. So when you're looking for hard mix, you have to program the optic to identify the hard mix paper so that it can tell the TOMRA deft air system to eject that particular type of paper onto the quality control belt, and then it lets every other type of material pass through. So I would just want to point out that each optic is looking for something different. It's only able to fire on one type of material. That makes them also way more accurate and able to move at a much faster rate. And then we have an elliptical. So after it passes through our two optics in our fiber section, our elliptical is another screen that is removing any residual paper fines from the three-dimensional containers. So at this point, our three-dimensional containers have made it all the way down the line, and there might be little tiny pieces of paper or little small pieces of plastic that have made their way through the line, but at this point, anything 3 inches or less will not get captured. As you can see in those openings, it still has you know, some size issues with really tiny microplastics and small pieces of paper, but what it is able to capture and what it does a really good job of doing is any residual paper that has made it in with our containers up until this point. So that prepares the containers for their sorting process, and it leaves a nice clean stream of containers. And then we have a magnet. So the magnet is fixed onto the ceiling. It's recovering any of our tin cans, soup cans, cat food cans, dog food cans, vegetables, anything like that that is ferrous. So it does contain a magnetic pull to it, and that's how that magnet is able to recover it. And then we have our 3 container optics. So we are able to identify 3 different types of plastic. Number 1, which is PET, number 2, which is HDPE, and number 5, which is polypropylene. So that's what, again, the optics look like, but each one of those has a different purpose, and that's to identify different types of plastic material. Our eddy current is the last step in the process. It is another type of magnet, but it is almost like a reverse magnet. So it's repelling the material that's not magnetic, so your aluminum cans and your non-ferrous metals. And that produces what's called a UBC bale, which is a used beverage can. So, you know, any of your beer cans, soda cans, and things like that will end up on our quality control belt for UBC. And last but not least, at the end of each of these lines is a bunker where the material is stored until it's ready to be baled. And we have 2 balers working in tandem. We have a 3-ram baler and a 2-ram baler, each working simultaneously so we can bale multiple materials at one time. Here you do see a picture of shredded office paper being baled. So if you remember that graphic I showed you guys earlier, shredded office paper is not accepted single stream in your curbside bin. However, it is a separate material that we take through shredding companies and commercial businesses, and it's sold as a different commodity and is a very valuable material, but as you can see, it's very messy, and we try to eliminate that from our single stream material because it would not make its way through the screening process and can get very messy. All right, so enough of me talking. I'm going to show you guys a video. I do have captions. Hopefully they work. The video is about 7 minutes long. I know it's hard to hear it, but I'll put those captions on. Uh-oh, it's hard to play it too. Let's see. It's just my computer giving me a hard time. So, bear with me for a minute. I think it's frozen. Oh, let's do. Martin, you want to see if there's any questions up till this point while I try to figure this
Sure.
thing out?
Sure. And, I'm reminded by one of my colleagues that, if you want to play it from, it doesn't, if you have different sort of links that you can use, and, we probably would see it, but, I'll let you deal with this for right now. We did get one question from Frank Gardner, who said, are your optical sorting devices able to see the black plastic food containers?
That's a very good question. Right now we are working on upgrading them because there is some new infrared technology available that does a better job of seeing the black plastics. However, it is something that is hard to detect from an optical sorter because of the way that the light reflects off of the black conveyor belt. It doesn't really see it very easily. There's also robots that are available today that do an okay job, but again, it's very hard to see. So what we opted to do, which we think works the best currently, is just have our manual sorters pull all of the black plastics off of the QC line and put them in totes so that they can place them in the correct bale afterwards. Most of them are polypropylene or PET. So our end market will take them, but we often have to manually sort them. That's a great question.
Great.
I have the video. I'm just gonna stop sharing my screen for a second so that I can pull up my video a different way, and then I'll share it with you guys. I'm not sure what's going on here. If there's any other questions, please let me know.
Sure. While you're doing that, one question is from Paige Wilson. What is the estimated cost to build a facility like this, and how much does it cost to operate each year?
That's a great question too. So our investment was about 15 million at the time we were building our plant. We had one optical sorter for plastics that we reconfigured to be our PET optic. Each of those optical sorters at that time in 2020 were about $500,000. So it really just depends what you're looking to do. I know a facility that's going up in Ohio that's spending $70 million, and you really want to look into your end markets and see what your return on investment would be, and also take into account the labor and maintenance costs. It's not cheap. We pay our sorters pretty well. We give them good benefits. So, and we have, like I said, 50 people that are employed, and that includes the director of the operation and administrative staff. So yeah, it's very expensive. And the maintenance costs alone, I mean, if one conveyor belt rips, that's like a $30,000 cost to replace some of those conveyor belts. It's hard to find certain parts these days. I definitely think it's better to invest in the higher end, more expensive equipment. I mean, there is some cheaper equipment available out there on the market, but you will find that there's more problems with that. We're also very fortunate in that the guy who installed our system from Van Dyke now works here. So he stops for maintenance every day, and he has trained the guys to do most of the repairs in-house, which helps us cut some costs. But yeah, so the initial investment's 15 million. It's a pretty expensive division to run. So hopefully that answers your question. I do have the video, so I'm going to now I'm playing it on YouTube, so I'm gonna let the ad play because
Okay.
This is not sponsored. Okay, so let's see. Let me start sharing my screen again. Do screen one. All right, is everybody ready?
We're seeing the screen, yes.
Okay, the captions are on, and I'll hit play, so let me know if you can hear it.
Not really much sound.
Not much sound.
Mhm.
I'm Christian Morgan, the brand manager at Mazza Recycling's new state-of-the-art facility. And let's get started with the tour. When material first arrives at the facility, it's dumped onto the tip.
Yeah, we're not really getting the sound. It's kind of disoriented, but people
just
hopefully
clicked
can
something.
read the captions.
Produce a consistent feed. The material then travels up an inclined conveyor to the first sorting platform, which is a pre-sort platform.
It's telling me there's network connectivity issues, so that could be another reason for the.
They're also
That's the
removing
pre-sort.
screens, such as garden hoses, plastic film, wires, and things of that nature. The first half of the system is designed towards removing fiber and glass from the string, while the second half of the system is geared towards separating the metals and plastics. The entire system is designed to sort and separate commodities based on size and shape. And we do that by using screens, magnets, and optical sorting equipment. Cardboard screens and paper screens have different size openings to separate those materials. And in addition, there is steep incline to separate two-dimensional material, three-dimensional material. The material that goes up and over the top of the screen is referred to as the positive sorter, while the material that falls through the screen or off the back of the screen is referred to as the negative sorter. After the material is pre-sorted, it hits the cardboard screen. The cardboard screen has large enough openings that most of the material falls through that screen. The material that goes over the top of that screen, or in other words, is the positive sort of that screen, is cardboard.
There's OCC there.
Top of that screen, which is why the material then travels onto the quality control conveyor, where employees are pulling out wrappables and other large flat pieces of wood, plastic, and they appear over the screen. From there, the material travels to a bunker where it's bunkered. The bunker is full, it's baled. Cardboard is physically the largest commodity in the stream and is removed first. After the cardboard is removed, the balance of the material travels to the glass breaker, where the glass is removed from the stream, stacked, and bunkered. After the cardboard and glass is removed from the stream, the balance of the material travels to the first paper screen. Again, the paper screen is utilizing the steep incline to separate two-dimensional material from three-dimensional material, and also has a sizing feature. Paper is positively sorted from the stream. It travels to a quality control conveyor, where employees again are pulling out wrappable material, any kind of garbage, plastic bottles that may not belong there. After the paper screen, the balance of the material travels to an optical sorter and an elliptical machine, which further remove the remainder of the paper from the stream. That paper also travels to a quality control belt where employees are QCing the material. So at this point, we've removed all the bulky materials that may damage the equipment. We've removed the cardboard from the stream. We've removed the paper from the stream. And we've removed the glass from the stream. The only thing that remains is the plastics 1 through 7, aluminum cans, and tin cans. Plastics and metals then travel up a conveyor belt under a fixed permanent magnet where the ferrous metals are removed from the string bunkered, and baled. The remainder of the stream then travels to the first plastic area, which removes number one plastic, PET, which then travels to a quality control conveyor belt, it's QC. After the ones have been removed, the 2s through 7s and the aluminum cans then travel to the second sewer in the plastic area where the 2s are removed from the stream. The 2s then travel to a quality control conveyor belt, where they're not only QC'd, but then HDPE, or 2 plastic, is separated based on whether or not it's pigmented HDPE travels to the bunker and into bale, while natural HDPE is separated mainly by another bunker. All that remains at this point is 3 through 7 plastic and aluminum cans, which travel to the last optic in the plastic area, where number 5 plastics, or PP, is removed from the stream, travels to a quality control conveyor belt, and is bunkered and baled. The stream at this point then passes over an eddy current separator, where aluminum cans are removed from the stream. The aluminum cans are QC'd, pulling out the styrofoam, undesirable plastics, bunkered, and baled. The negative sort of the eddy current separator ends up on the trash belt. The trash then travels to a quality control conveyor belt, where the trash is QC'd and any valuable plastics or metals are removed from the trash.
All right. So that is our video. I'm sorry about the sound. I will pause sharing my screen again. That's pretty much the MRF on the inside. I'm, again, sorry if it was hard to hear. Hopefully you guys were able to read and follow along. And that really concludes our presentation on our material recovery facility. If there's any more questions, I'm happy to answer them.
Well, first of all, thank you for your presentation. And not only thank you for your presentation,
I can't
thank
hear
you for
you, Martin.
Oh, you can't hear me? Not now?
Oh, it's me, it's not you.
Okay, great. Well, I wanted to thank you not only for your presentation, but for your tech skills to figure out how to get that video up against some very challenging circumstances. So it was great, and it was good that it was captioned. So at least if the sound wasn't going along, people were able to follow along. And generally, thank you for the overview. Really appreciate it. We do have some questions here. One is from, and we got a comment from Frank saying, no worries about the sound. It was a wonderful presentation. That's from Frank Gardner. So verifying what I was saying. So thanks for that, Frank. Paige asked, what materials come out with the least amount of contamination versus what has the most amount of contamination? And how are you trying to improve the efficiency to recover more of those materials?
That's a really good question. I would say most of them, it's pretty consistent. When you look at a higher volume, like an OCC, which is the highest volume in the fiber side of things, a lot of that just because of, burden depth and material getting wedged in with other larger pieces of cardboard, that probably has the most contamination. And we also have the most quality control there. We put 3 people alone just QCing the OCC line. Same thing with the PET, which is the #1 plastics. Once you get over to the other side and you're on our plastics, one of our plastic lines, we need multiple quality control people over there because there's a high volume of PET, and a lot of times cans or things that are kind of stuck in a bottle or something like that can be harder for the optics or the technology to pick up versus a human who can see that very easily as it's coming. So we usually just put the most QC there. But other than that, things like polypropylene and hard mix, newspaper, things where there's less of that material. The optics do a really good job, but there's not a lot of contamination there, unless again, it's something that just got stuck or fixated to another piece of material. Does that
Great.
answer that?
No, thank you. And then there was a question also about contamination sort of from the other end. Jennifer Griffith wants to know what percentage of incoming material is actually trash that gets removed in the pre-sort, and also how much later in the process. And a related question about what efforts does the company use with clients to try to improve that quality of material coming in?
All right, so that's a big part of what I do, is try to educate the public, because the percentage does change. That's a good question about the pre-sort percentage. I've never really heard that one, but keep in mind at the pre-sort, they're looking for those bulky plastics, bulky metals, and film mostly. So there is a rather large amount of film. There's also some material that comes bagged, so they have to rip the bags open, and stuff like that happens. But that plastic and that metal is getting recycled, so there's probably a smaller percentage of what the pre-sorters are looking for that's considered trash. However, overall, the material that comes in on the tip floor, that large pile, and then the smaller pile that gets sent to the landfill, that varies anywhere between like 12% to 20% of overall material, and that could be because of wish cycling. You know, we see a lot of non-recyclable materials in there. It also could be because of the season. So during holiday season, there's a lot more film and you know, things like wrapping paper is not recyclable. Certain kinds of wrapping paper, I think the brown craft paper is usually fine, but so the 12 to 20% could mostly just be things like you're saying, that people just aren't aware of the recyclability of it. So our message tends to be, when in doubt, we'll sort it out, because we have the optical sorters to do so, and because we have that advantage. So it's a little bit better for us to throw everything in the recycling bin and give it a chance of recovery. So, you know, we have that one side of our public education, which of course would increase maybe in some aspects the landfill pile, but it also does increase the capture rate and the amount of material that goes to a recycling facility. So generally, though, I try to do a lot of these presentations. I try to go into towns, hand them resources, tools, share that video. Our YouTube channel is great. That video has about 40,000 views now. So I try to share as much information as possible. And also, one of the initiatives that we have is our Greener Tomorrow program. So we have tours of our facility where we allow people to come in, students, residents, big corporations. Colgate Palmolive is one that we are good partners with. They have a lab in Parsippany, which is not too far from us, and they're the ones that manufactured the new HDPE toothpaste tubes. So that's something that I have to educate the public on as well. So we have a really good team here, and a big part of that team is community outreach, and that's a big part of what I do.
Great. Thanks for that. Paige wants to know, have you considered investing in a foam cycle densifier to start recycling styrofoam?
We haven't personally, because one of our partner towns, Middletown, they are one of the largest populated towns in Monmouth County, which is where we're located, and they have one. So I usually tell people to bring their styrofoam to them. It's easier when you have like a local place that's doing it, to kind of just like put all your energy into one facility, because styrofoam you need a huge volume of it in order to produce enough to move. So we'd rather just team up with them and have as much styrofoam as possible go there.
And you know, I was just curious, you know, looking at your tour and all the different ways things are getting sorted now. Can you preview what sort of the next coming technology is? Do you know what the industry is working on next to further improve, you know, recycling capabilities? Is there anything you can tell us about that?
Totally. So the optical sorters alone, I mean, there's tons of upgrades. I mean, if you have an iPhone and you know that they come out with the next iOS model, they're always doing like little tweaks like that to the software aspect of it and to the artificial intelligence. So there's, you know, the auto sorts number 1 through 4, and now they're coming out with the auto sort 5. So there's always upgrades to software that help things be more efficient. We're also looking into just kind of widening some of our belts based off of the volume. Like if polypropylene is something that's going to start being used in a more widespread way, that might be one of our belts that needs a little bit more room on there. PET, we already know there's a large volume of it. So there's a bunch of little different, you know, like facets of the actual structure itself. But one thing that we're really monitoring and kind of keeping a close eye on is robotics. We don't have any in our facility now, but we do have an AI scanner, which is the brain part of the robot. And then we can also add arms that have a little bit slower of a pick rate than an optical sorter does. You have to kind of think of it more like if your human brain can be trained to find something, like a robot brain can too. So it's not really as much of an efficiency thing. It's just really good for any of those trash lines or quality control lines. Like if we have somebody that's only standing on our residual trash line 50% of the time, we have an AI scanner there now to try to collect some data to see what material is coming down that belt the most. So like, let's say it ends up being UBC, then we'll put a robot mechanical arm in there that's trained to pick out that aluminum can from the residual line. So there are some good things that robots can be utilized for, but I definitely wouldn't rely only on robots. I wouldn't rely only on optics, and I wouldn't rely only on people. You need kind of a mixture of everything.
Thank you. A question from Paige: how many tons of material do you bring in each year to offset the operating costs?
Well, we really, when you build a plant this size, it needs to constantly be moving. Ours was actually designed to do 25 tons an hour. I think when we originally were working with Van Dyke, and we kind of guesstimated how much material we'd be able to take in. Now we're in Monmouth County, we're at the Jersey Shore. There's not a plant like this around, I can tell you that for sure. So we ended up taking material from a lot more counties than we did previously. So we're going at about 40 tons an hour now, and that's how far we can push it without it being less effective. So it was designed really well. We work a lot with the Van Dyke team. We're constantly, you know, keeping up with the latest technology and trying to see how long we can stretch out this system, because it's only 2 years old, and you know, you already start to see problems with it arise pretty early on. So cleaning everything, making sure it doesn't get dust all inside the system or inside the computers is important. So yeah, I'm hoping I answered that question. And then also our plant manager, Carlos, who used to work for Van Dyke, he understands how to make everything work. So we try to keep our operating costs and our maintenance costs down and bring that 40 tons per hour of material. We did 125,000 tons in our first full year. So we try to consistently stay at that, and depending on how the markets are, which, you know, this year they weren't as good, but depending on that, the return is pretty good, just because we do a good job of keeping our operating costs down.
Okay, terrific. You got another thank you, great job presenting from Paige. Thank you for that, Paige. Any other questions while we have Brynn here? I'm just going to scan and make sure I haven't missed anything. No, it looks like we don't have any additional questions. So once again, this recording will be up on the NMOA website along with the materials. And once again, a very big thanks, Brynn, for your presentation. You're getting the video, but more than that, your insights in walking us through how a MRF operates. It was a really great presentation. You can tell from the questions a lot of interest from our attendees. So once again, thank you.
Thank you so much for having me. Everyone, thank you for joining in. I hope you learned a lot today, and I will send my slides to you, Martin, so that you can share them, and feel free to share my contact information as well.
Sounds terrific. And thank you, everybody, for joining, and I hope everybody has a great afternoon.
Bye, everyone. Thank you.
Thanks.